Alright, this is the introduction for the ideal gas law lab, and more or less what we're going to be doing is we're going to be taking a look at how the pressure is affected by the volume, the number of molecules, as well as the temperature. So here's kind of what we know is we know the ideal gas law, PV is equal to N times R times T. So what we would kind of expect is for the pressure and the volume is if you hold all these guys constant, I would expect an inverse relationship. If we were looking at the pressure and the number of moles, I would expect a linear relationship because as this goes up, then this should also go up. And lastly, I would also expect linear for pressure and temperature because if the temperature goes up, then the pressure should also go up, and vice versa. So we're going to start off by taking a look at the pressure and volume, but before we go through that, let me walk you through what you need. You need a pressure sensor, you need a temperature probe, a beaker, an Erlenmeyer flask, and a calorimeter. You also do need some water, and my public safety announcement, when it comes to the water, it comes screaming out of these faucets. Please be very, very, very careful. So here's what we need for this lab. We need the research grade calorimeter, that's for the very last part. We need the pressure sensor, which is going to be this guy right there. Note that the tube on it right here is probably initially connected, and you want to disconnect it for the first two parts of the experiment. We need the temperature probe for the pressure and temperature part. We also need a glass beaker, and I have a little teeny tiny Erlenmeyer glass kind of hiding behind that guy. This is the syringe. Hopefully I remember to get these guys out, and we need the hot plate for the last part of this experiment. So the very first thing you're going to do is you're going to hook up the syringe to the pressure sensor. Now you kind of have two ways to do this. Is you could hook the pressure sensor up to the tube, up to this guy right over there. That is not the way you want to do this. I don't want to have this volume affecting anything. What you want to do is you want to disconnect the tubing from the pressure sensor, and you want to go ahead and directly connect the syringe to the pressure sensor, which then goes to the computer. What we're then going to do is we're going to start messing around with the volume, and what you're going to do is you're going to start with the piston initially at the 5 milliliter line on the syringe. You are then going to connect it to the syringe and read the pressure and volume. Pressure is going to go right here, volume is going to go right here. It should be roughly atmospheric pressure, or 101 kilopascals. You can then calculate what the pressure times the volume is, but you can do that on your own time if you wish. You're going to pull on the piston until it hits 7 milliliters, and you're going to do this a couple of times, increasing the volume and increasing the volume. What you can then do is you can then go ahead and calculate the product of the pressure of the volume. Now, you're going to say, is it constant? Well, it should be. It's probably not going to be exactly a constant, but it's going to be close. What happens is these guys are going to leak. So as you're doing your measurements, make them as quickly as possible. So you want to go from 5 milliliters to 7 to 9 to 10 and so on and so forth. So you want to do that as quickly as possible. If you want a few more data points, you could also push it down to like 3 milliliters and it would work just fine. What you're then going to do is you're going to put these guys into Logger Pro, and you're going to do an inverse fit and just record the pressure, or record the coefficient, and what should that coefficient represent. Then what we're going to do is we're going to take a look at the pressure and the number of particles, and so we're going to start off with certain volumes, and we're always going to go to the same volume, essentially messing around with how much air. Now, it's very, very hard to measure how much air, so we're going to talk about puffs of air. We're more or less going to say 1 puff of air is 3 milliliters of air, and we're always going to pull the piston such that it reads 10 milliliters. So what you're going to do is you're going to increase and decrease the number of puffs, always going back to 10 milliliters. Now, kind of what we would expect is we would expect a nice, pretty linear relationship. You do want to make these measurements as quickly as you can. The reason for that is because these things leak. what you're then going to do is you're then going to do the pressure and temperature measurement, and for this we no longer need the syringe. We do need some cold water as well as some ice and the sink. So what you're going to do is you're going to go ahead and connect the temperature probe, and you're going to change the data collection to selected events. This is going to let you say keep certain times in a very easy way. The Erlenmeyer flask is going to be the container, no longer the syringe, and what you're going to do is you're going to connect the tubing to the pressure sensor, and the other end is going to go to the Erlenmeyer flask. You're going to take the calorimeter, the styrofoam cup. I know the picture right here shows a beaker. What I found is it's just a little bit safer using the beaker or using the calorimeter than the beaker, just on you. So it does make a note of that. You're going to stick the temperature probe in right here, and you're going to pour about 200 milliliters of boiling water. 200 milliliters is not a hard and fast number. Just try to cover most of the Erlenmeyer flask. You're going to wait until the pressure and temperature stabilize, and you're going to click keep. Then what you're going to do is you're going to dump out some hot water, and you're going to replace it with some cold water, or you could even use some ice if you really wanted to. And you want to drop the temperature by 10 to 15 degrees. You're going to go ahead and click keep, and you're going to do this 3 or 4 more times, dropping the temperature by 10 to 15-ish degrees each time. Once you hit roughly 20 degrees Celsius, what you want to do is you want to start adding some ice to the water bath and dropping the temperature even more. Once you get it to probably less than 5 degrees Celsius, we're going to call that close enough. Go ahead and stop data collection. It should look nice and pretty and linear, and then what we're essentially going to do is we've mapped out this piece of the curve right over there. You're going to extrapolate it and see if the intercept is indeed 0 Kelvin as you would expect.